Hi everyone, I'm Irfan Sheikh. So today we are gonna discuss the RAG PDF embedding MapReduce system. So this is based upon the course which I have taken at University of Illinois Chicago, and this is a course is CS441. So the initial map Richanic and this is my homework one. Today I want to discuss this table, or let me directly go into the whole project. So this in this project we have a project overview first. So this what is saying here is we have to implement the RAG model. What is RAG? So augmented generation system. By how? Is it a local host or a cloud environment? So I'm here using a cloud environment by using Apache Hadoop MapReduce framework. So what I am doing here is just to process the PDF documents at scale level. So I want to analyze how these PDFs are being generated and how this gonna be used in the, like we can say, the data science field, and what are the characters we have to take. So we can use this in data related. So is we are just doing a RAG model, so just taking extracting a text and doing the chunks, then generating embeddings using your Ollama. So I use MXB embedded large model and aggregating the data by using a MapReduce concept and just creating an output results from there. So let me directly go to the first uh, Amazon EC2 instance because it's take a time to. So from here I will create a cluster. So simply I will clone the cluster here. So actually, I already created just recently, but my laptop is restarted again. That's why I want to try it now again. So, so these are the configurations I have taken. First one is my name. This is a release version of EMR. So I have taken this core Hadoop. Just I have clicked the core Hadoop. That's it. Then I have choose the m5.xlar. So I prefer you to take the g5.xlarge because in g5.xlarge we will contain the four virtual CPUs, but here we will I have uh, not a GPU. I have just only CPUs, only four CPUs. Let me what does four we call. But there we will get the four VRAM, so it's a core is increased, so it may be easier to take a G5. In my case, the AWS administrator didn't assign me. I had given a request, but they didn't assign me. That's why I'm just using this. But it's fine to use this, but it's better to take the G5.xlarge. The next I am taking this PPC is a common thing. So I use this RAG EMR is a customized jars which I have taken. Then we can use this law API just to see the logs. So this is an important thing just to debug ourselves. And the next thing here is I choose the audio key just to SSH because why this is important here? Because after the computation cluster of completion of the EC2 instance, we need to download the old Llama model. Special Ollama model we to create by using SSH of that EC2 instance. That's why we need this SSH key pair just to connect my cloud environment of EC2 to the local environment terminal. So for that we need this key. Okay. Next thing here is just using this instance preferences and cloning the cluster now. So right now, let me check what is it's in the starting stage. So then it goes to the running stage. Then it goes to the waiting stage. So after waiting stage, we will get the thing. So now we'll see. So this is the bus S3 buckets files which I have. So in input file, I have put this files. But at the end of the day, this is for showing, but at the end of the day, I will take a path of this file. So I have created one separate file here in this file. So where this to take a path of this PDFs, just very simple. Like if even if we can also give this is the path. That's it. This is the path of that PDF. So we can use that just to we can just if anyone can we can do that in this we can get the text file of this all paths. Okay. Then next, after completion of this cluster, then we will getting here an output file. I will show you after completion of this file. Then the output files there will be the shards. Now next, here it's still starting in more. Starting, still starting. So we will go into concept now. So this is in a system architecture. So first thing here is the data. And so this is a RAG model. It's not here. We are not creating an LLM like we are just ragging by using the LLM model. So don't think that we are creating an LLM. Basically, it's just we are using a concept of MapReduce framework, which is implementing Hadoop. We are just augmenting, we're just retrieving the data from a particular source, and we are using that source and just filtering, and we are making some potential information with that source. Okay, so this is the main funda we have. So this is the main funda. So we are getting that, and we are using that those source information to the a yield, a good yield. We need information from here. I have put in those all. I have kept those all files in S3 bucket. So from there, I used to call the mapper function. So basically, I used to start from there. My map reduce driver it starts from there, then it goes to mapper. So what is the characteristics of the mapper here? It's just it's extract the text from the PDF and it's a chunk it and get embeddings. So where we get the embeddings, we will get the embeddings from the Ollama model. Okay. And the next thing, we are getting the embeddings, we used to make that as a shard. And and another day we'll get a shards and from reducer we will just aggregate it. It's nothing but a hashing function. We're using a hashing function here. Now I will explain you this deeply after combination of this. We're getting a JSON format embeddings. I will show you that format. Then we are using Lucene indexing. So why is it, we can the Lucene indexing? We can just check that how our embeddings are going to create. And what are we can also test if the bill of an index, like if you give one example word, then it shows you the frequency of that word. Mm. Then we can also give do the RAG query and answer. You just with the easier question, then it is the answer. Then next thing here is let me check again here whether it is starting. I will refresh it back. It is still starting mode. Okay, now we will go back to the PDF. It's in the component responsibilities we had. Mm, Basically, we are just what are we explained here in this architecture. So this is an roles which is going to which is executing by the respective components. The PDF embedding, like I said in there. So here is Ollama client because this Ollama is I'm using a MXBI large embed, so it's take the chunks and give the embeddings here. That's it. And what are the software installations we required? So I have kept here mentioned here. It's a Java. So I use a Java 17 version. So you can use probably 17 or 20. It's your wish. And the Scala updated, and it's very important to get them to download the SBT because to get whatever the Scala code which we have written, we need that code convert into a jar file. So for the jar file and for the entire processing of that Scala code, we require this SBT. We can install here, so you can install here from this website when doing these commands, or you can also directly do with the IntelliJ. Or mostly I did with the in terminal homebrew. So it's basically easy thing. So I can't suggest, but that homebrew will do everything easily. So I use that. That's it. And Ollama is a similar. So I have just put these, and you can just go with these presentations. It's very easy. You can also do it the homebrew. And this Hadoop is we can just what are the cluster which we are creating there. Mm, the cluster we are creating here. So at the beginning of the time, we have to select the Hadoop versions and AWS EMR version. Yeah, I have just download also git demo from the terminal. So it's very easy. You can just download the git CLI just to push the updated files. So because always getting those files and or pushing those in GitHub, so it might be it's not easier. So I prefer to use this. And I have used uh, the m5.xlarge, so I didn't use any uh, GPU. I just using the CPU because yeah, that's what already mentioned that I tried with the administrator, but they didn't assign me the GPUs for virtual CPUs. So that's why I am tried with the. But I suggest you to do with that G5.xlarge or G5.x2 xlarge, if you wish. For the .x large, we need a 4 virtual CPUs. For 2 on .2x large, we need a 8 virtual CPUs. That is the installation guide of Java and everything Scala, SBT. So it's a basic structure which I have mentioned. So you can go with the presentations of PPTs, and these are the basic thing. The command is you have to put your GitHub repo URL. And just after completion of the code, just write SBT clear and SBT assembly. Well, it converts into fat jar. So this jar will go in. So I used I didn't try. I just tried with the localhost command. I just use the SSH here to push my jar file into my S3 bucket. So here to push here. So this is my jar file. Okay, this is my jar file, right? So yeah, see here the RAG MapReduce.jar. This file here is a RAG MapReduce.jar. So this is my jar file which are given there. Then this is a project structure. Let me go back to the. Let me see here if it turns to a running state or not. Yeah, it's running now. So we have to still wait with after completion of the entire file PDF files. So maybe it takes us some more couple of minutes. We will complete our project structure here. So this is very basic project structure which I did. Mm, PDF embedding mapper.scala. So it's similar to the structure which I already discussed here. So I just converted these into my project structure so that you guys became able to understand easily. And I also mentioned the hashtags. So what is the what is the mentions for and text chunking logic or Llama client Scala PDFs. What's embedding mapper is doing a mapper implementation. So they said so after completion of this we will do this analysis part. Okay, before this analysis part, we will do the post processing. After completion of this post processing, we will do the analysis. Okay, and then next here, I just tested the here. This is testing file. No need to worry about that. So I'll also show you the how my dependencies, what are my dependencies in build.sbt. I will show you now itself so that you can easily understand. So this is my bit I use for this of SSH to for parsing. I just for use browsing. I also mentioned for the command so that you can easily understand why this dependency is used for. So then next one. So these are the so you can basically this is my SBT file. Next is local. This actually I tried first with the five files with the local testing. So then I got these type of outputs. Then I tried with the local. Then I got some embedding. So it went fine in local. Then I tried with the AWS. Then so so I in my opinion the local testing is easy, but maybe I don't know how AWS EMR you have to be make sure of everything parts of the inbound rules and the traffic. You have to manage the traffic. We have to connect the Ollama with through the SSH to the EC2 instance, and we have to figure out a lot of stuff there. So be make sure with that. So I have shown I have already kept this my commands. So I use the US. You can put your bucket. I just mentioned the what's the command here. And next go over that. So there's a text files which I'm giving as an input. I already mentioned this. I am going. I'm not giving the entire PDF. I'm just giving the path of that PDFs. Then I just uploaded to that S3 that hopefully you can see that in my S3 bucket. Then next here uh, create EMR cluster. So this is the cluster. So this is the important thing you have to download while you are creating the cluster. If it doesn't have, it's not a cluster. So while creating the EC2 instance just for Ollama server, we need this keeper. Okay. So the basic structure I can say here while opening the well, first go to the AWS, then try to figure out to create the EC2 instance with the g5.x large. Then try download the Ollama. Then just connect the Ollama to the SSH. So this is the basic structure. Then next creating after that just after completion of that entire Ollama configurations, then just come with the EMR cluster. Just create the EMR cluster. It's very basic thing. Okay? Just by seeing implementations you can do it. And next one here is the jar location. So I just put the jar location in my S3 bucket. So I'm giving these arguments in this manner, but I tried with the what actually like I already given in the script so that I can always I don't want to always keep putting my jar files if I did any changes in my jar file. That's why I did push that through the commands of SSH. Then next one here is file dependencies. So these are I already shown you these things. And yeah, actually, while doing these, I got some lot of issues, but I am mentioning a couple of issues so that you can get the thing. So how much is the way? So this is the understand. So these are some commands to run. Like this is the command to run. So this is not the perfect command. It will give you enter the correct path. So I have to change it. So these are some commands to you can test the Ollama server by using this one. And end of the day we have to SVT clean assembly. So that's it. So this is a very basic thing, and it's a good project. If you do it, you can learn a lot. It's still in a running, so we have to wait till it comes under the waiting period. So next complete with the overflow, then we'll go to the code part. Next one is a here map reducing EMR. This is important. That's where we're getting into download results and merge output and it's getting the charts. The charts will go there. So the expected results. So at the end of the day, we so by using a build Lucene, we can find out the frequencies and Lucene index builds sufficient. We can also ask some questions by using. We can ask the Lucene questions. So, but it makes it a good time because that's why we have to use g5.x large for this especially because I tried once already previously, but my system got hanged out because of my low computations of my EC2. So I used to prefer to take a g5.x large or d5.x large to do this especially. Next one here is a so these are some troubleshooting which I faced in my running the code. So just two steps to how to initialize the Lucene indexing. So it is a post-processing concept. So I will show you where I put those. I will also explain these things. So these are the results. I already did the before. Just I want to keep you that to understand how my answers will show like. Then from the resource main. So these are the configuration files. So this is the main file. So don't worry about this main.scale, but actually I focused here. This we can consider the RAG MapReduce driver is a main file. Then mapper, then reducer, then mapper will call chunker. It called the Ollama. Then it goes. It first start with PDF mapper. It just go back to reducer. So that's it. So it's a very basic thing. Then after coming, we can do analysis. Here we are doing analysis part, and we can also show the post processing. This is an analysis, so this is a post processing. Here we are building the files. We will go in depth. Okay. So expected output may this we will get these type of outputs if right. Not only these things, we will get a lot of outputs, but this is just to understand here. Okay. Next, so this might be my part or JSON files. So yeah, this is so let me check again here. My it's still in a running. Maybe it won't take much time because you can get it in 2 to 3 minutes because when I tried I used to get 20 minutes or 25 minutes maybe. So we'll have a good time to see our code as well. Go here. So this is my build.sbt. I'm just removing that. This is the entire script which I've written just to connect my just to connect my AWS with my local. So it's for me this one takes a lot of time to figure out the things. If I got any error, I need to come back and check and do the things. Yeah. So this is the bit I can understand. So this is my main file. So from here, these are some test cases. If I don't give input path and output path, I have to get output. I have to get error. So that's why make sure I'll also mention what type of input we required and output, everything. It's everything is good, and I also mentioned it in the comments there so to understand. So what is doing what? So from here, yeah, I'm running Ollama. I'm just calling the map reducer. So we just go to the mapping, and from here we it takes a one path, and that path will go to this chunker, and I can show you the chunker file here. So this is my chunker file. Next one here is after going to that there is creating the Ollama client just to embed and to do the embeddings here. Then after completion of this, that's it. So we are good to go with the map reducer. So in the map reducer, so it just take those all embeddings from where it's getting and just it's converted into a shards. Okay. It's just converted into shards now here. Sorry. Yeah. This is converted into shards. Now then. After completion of this, so we will go on to the build scene, then we will try to do ask Lucene. Yeah, build Lucene as a social token. We will do it once if we complete with the cluster, then we can do that. Maybe it may take a 2 to 3 more minutes to complete this. So we can wait till the so or I can I want to explain. Okay. So yeah, okay, I'm just giving an input from my local. It's giving how many frequencies of that word has. So if I give you any text, so in the text, what are the words I have got? So it will give you the respectives. Okay. Then next thing here is search Lucene. So in search Lucene, what we do here is we will search the so couple bunch of keywords. We'll search the bunch of keywords. So from that keyword, we will get the how many frequencies we have, what are the frequencies we need to use that. Next thing here is a token stat. So we're going to create this. I will show you step by step of the completion of that things. Let me pause my video till here. Yeah, we can see here the way of after the running state we got into waiting state here. Then if we go into the buckets of previously we have only input bucket and PDF semester. Let me check how many buckets we had. In this PDF semester we have three folders more. One is the input folder we already created before the jar is also given as an input. So let me check see an output. Here we have four outputs. So this is the main importance of the homework. So the remaining part, the post processing part is very. I mean, it's just an intuitive. Just we can do it by our own. So let me go into that post processing part as well. So yeah. After getting or got executed. So we can do a couple of things here. So we can check whether are we going to get or not. First of all, we need to over the memories we got. We need to merge as a txt text file. So for that, I will run my build Lucene runner so that I can get a text file of the embeddings which we can use for the Ask lesson as well. So it is in a 10, right? Yeah, this one. Okay. So from if we check here, Bill Lucene, so we are getting a merge.txt. Like other man, I got this merge.txt here. See, I got the merge.txt. Yeah, this one I got it. Now next point here is we are going to do with the we can do whatever we can do with we got a merge texticle, right? So we can do ask listen, we can ask the questions, whatever you can ask like mm, you can directly ask this question, explain neural network orchestration. Mm, and you can ask in a different yeah. So after build Lucene, so we can ask the computer the Lucene, we can ask direct question and answer statements. Then we can go to the search Lucene. So if I show you that search Lucene now, so this I have given this input your query text here. So it will check the how many. It will just understand. So oh, it's a score of mine. This one is 7.35. So on an average, I got the 7.35. So like this, we can understand. This also, we can also get the duplicates, obviously. So my yeah, score is pretty bad. It's good. Next here. Maybe we can understand the token stats. So now next we can go to the token stats here, from where we can get an CSV file. So we can check how many CSV files we got from here. So used to get a good number of CSV files. So let me check how many I can get here. So it's succeeded. So let me check in my here. See, I am getting this A 30 frequencies. So I got an abstract of 10 keywords. So from here we can filter out the whatever we require. So we have to do some more filtration process there. So we can these all the water this is a post processing, so we can just analyzing. So how many frequencies are there. We can also dragging a question that how many neural networks, what is the meaning of neural network. So from the ask Lucene, we also did some search Lucene, so how many keywords are there, and also converting this into the CSV file. So this is pretty good actually. It's this project is you can understand what is the AWS concepts you can get. And moreover, the last point here is just we can do an embedding evaluation. Just I have taken that example here, which you provided by a professor. So I tried with that. So I also implemented those in this format. So maybe I have to run it so you can understand what is the output of it. After getting the embedding eval.scala, so I have just go through this, and after running with this, so we will get an embedding. So I just created that. So I have got this analogies. So this is my entire project. So this is a very basic project. Actually, I heard our professor's book is helped a lot because it has an everything, and especially yeah, doing a research, just trying to do a workout. So it might be a lot of fun. So I enjoyed a lot by doing this project. Yeah, it's really a quite good opportunity for me, instructors, which we have this type of learning from him. So I used to prefer. I suggest you to take this CS4 for one to my juniors as well to learn a lot of things from these type of projects. And yeah, that's it. Thank you. Thank you for giving me this wonderful opportunity. Yeah, see you. Bye bye.